Hello, science lovers, and welcome back to Let's Learn. Today, we're unlocking the secrets of one of the most powerful tools in all of science, the periodic table. It might look like just a colorful chart, but it's actually the ultimate cheat sheet for understanding the entire universe. So what exactly is it? Think of the periodic table as a masterfully organized library of all the fundamental ingredients that make up everything around us, from the air we breathe to the stars in the sky. This incredible chart arranges all known chemical elements in a very specific order based on their atomic number, which is just the number of protons in an element's nucleus. Each element gets its own little box, complete with a unique 1 or 2-letter symbol. For example, you'll see H for hydrogen, the very first element, and O for oxygen, which is crucial for life. Along with the symbol and atomic number, you'll usually find the atomic mass, which tells us the average weight of an atom of that element. This systematic arrangement is what makes the periodic table so brilliant. It's not just a random list. It's a map that reveals deep connections and patterns between the elements. Let's start by looking at the columns. The vertical columns are called groups. Elements within the same group are like family members. They share similar chemical properties and often behave in similar ways during chemical reactions. It's all because they have the same number of electrons in their outermost shell. Take group 1, for example, the alkali metals. You have lithium, sodium, and potassium, which are all highly reactive metals that fizz and pop when they touch water. On the complete opposite side, you have group 18, the noble gases. This group includes helium, neon, and argon. These elements are the cool, laid-back members of the table. They are extremely stable and almost never react with anything, which is why they're called noble or inert. Understanding groups helps us predict how an element will interact with others without even running an experiment. Now let's talk about the horizontal rows, which are called periods. As you move from left to right across a period, you're adding 1 proton and 1 electron at a time. This gradual change causes the properties of the elements to shift in a predictable pattern. On the far left of a period, you'll find highly reactive metals. As you move across, the elements become less metallic. You then pass through the metalloids, which have properties of both metals and nonmetals. And finally, you arrive at the nonmetals on the right side. This transition from metal to nonmetal across each of the 7 periods is one of the most fundamental patterns in chemistry. It is like watching a character's personality slowly change as you read across a chapter of a book. But there's more. The periodic table is also divided into blocks, labeled S, P, D, and F. These blocks refer to the type of orbital where the element's outermost electrons are located. The S block on the left contains the most reactive metals. The P block on the right contains a diverse mix of nonmetals, metalloids, and some metals. The D block in the middle is home to the transition metals, like iron, copper, and gold, elements that are essential to our modern world. And those 2 rows at the very bottom, that's the F block, containing the lanthanides and actinides, many of which are radioactive. So why is this table so indispensable? Because it's a powerful predictive tool. By understanding an element's position, scientists can forecast how it will behave, what kind of compounds it will form, and even what properties a yet-to-be-discovered element might have. The Russian chemist Dmitry Mendeleev, the father of the modern periodic table, famously left gaps in his original version, correctly predicting the existence and properties of elements like gallium and germanium before they were ever found. The table is a testament to the underlying order of the natural world. In essence, the periodic table isn't just a classroom poster. It's a dynamic map that guides chemists, physicists, and biologists in their quest to understand and manipulate matter. It's the story of the elements and how they come together to build our reality. I hope you enjoyed this deep dive into the heart of chemistry. If you found this explanation helpful, please give this video a big thumbs up, and don't forget to subscribe to Let's Learn for more exciting science content. Share it with anyone who's curious about how the world works. Thanks for watching, and I'll see you in the next video.